Hello everyone and welcome to the online meetup with the GDG Cloud Bangalore and the Cloud Native Bangalore group. Sincere apologies for the delay because of the technical difficulties, but finally we are live and kicking. All right. So my name is Ransi, your host and the organizer for these meetup groups that we have, the GDG Cloud and the Cloud Native. So for today's session, we have Suman Chakraborty, who is going to be talking about making a cloud native deployment easy with Buildpacks. So Suman is working as a senior cloud native architect with VMware, who is helping customers in their app modernization and migration journey with Tanzu Kubernetes Platform. Suman has been a distinguished speaker in multiple conferences, and he is actively involved in many tech communities such as the CNCF Data Management Group, the Docker India, and Konfhub. So Suman is also certified on multiple Kubernetes certifications as well. So without further ado, over to you, Suman. Take it away.
Hello, everyone. So thanks, Runsi, for the nice introduction, and it's great to be back. And thank you, GTC Bangalore and the Cloud Native Bangalore community for giving me this opportunity to showcase the solution on one of the most modern approach of building application using Buildpacks. So possibly what I am going to show today, or the topic that I am going to discuss, is about how we can make life easy for the developers in a very much simplified manner using cloud native build packs. To start with, so as Runsi already given introduction, so I'm working as a senior cloud native architect with VMware, and I have been a speaker at the Open Source Summit, HashiTalks from the HashiCorp conferences, Devops India Summit, and Docker India conferences. I have been occasional speaker in multiple tech community meetups, and I mostly talk around technologies such as cloud native, open source, platform as a service, Kubernetes, DevOps, and the serverless technologies. While I'm not at my work or I'm not speaking, I love to travel around the world, and I'm a big foodie. So to start with, what are container images? Well, we all know by this time that container images are nothing but they are just a bunch of layers together with the configuration file. So when we say files, what are files? Files are the read-only entities within the whole image stack. Now, when we discuss about container image, right? So they contains multiple paradigms of informations or data which is fed across multiple layers together building a single stack. Now, in the modern day world, how a typical container image is built? Okay, well, there can be, I mean, multiple ways, but the usable or the most predominant way of doing that is using Docker file. Well, Docker file is again comprises a set of runnable instructions, which basically lets you tell how you are going to build your application, right from selecting the base OS image, executing the runnable instructions to install certain binaries or dependencies, running certain commands within that particular instruction set, and then finally executing that by starting certain services and exposing them at the container level. Now, the Docker file has been considered to be developers' best friend in Dockerizing polyglot application. So, well, it fits into every scenario, as we see, whether you think about building a Java application or think about building a Python application, the workflow remains almost the same. You basically build a Docker file, and then what you do, you basically uh, put it or provide it as input to the Docker daemon, which take it as a context and build it from the scratch. The important advantages using Docker file is that it basically helps in faster app development, easier management, and scaling of the containers becomes easy. While you have a single Docker file, you can edit and do changes multiple times as you need, and it basically helps us to speed up incremental builds. However, like to see how a Docker file looks like. So this is a very simple example of building a Nginx application where you basically specify the base OS image, how you are going to basically install the dependencies, like doing an apt-get update, and then installing the Nginx binary, making certain changes in the application source code configuration, doing certain permission changes, and then basically setting the work directory and exposing, and together you basically build it. Well, that's fine. And I mean, for a developer, it's bit easy because for him or her, it becomes very easy to manipulate this kind of an instruction based file where you can provide changes as required, right? But there are certain shortcomings in using Docker files. The most important thing is that the application image that you create is almost bloated with extraneous cache directory, which is not required, and this basically becomes a performance bottleneck sometimes when you are building a very larger image in the during creation, during the building phase. The next thing comes about the composability. Composability is where you have to sort out multiple dependencies that you need to transfer from one image to another image, which normally happens in multi-stage build conditions. Now, using Docker, it is actually possible to remove that using the concept of multi-stage build. But then again, there are certain caveats to it. Like you cannot specify environment variables directly while using the multi-stage builds. When you want to pass on some informations, you cannot follow certain symlinks for connection, and you can copy only the file system layers, and that basically restricts you basically copying any arbitrary files or directories that you need to. On the other hand, using Docker file provides a kind of a leaky abstraction it's basically a leaky abstraction model for the developers, because the developer simply wants to focus in basically building the code logic. They don't want to go and try to figure out what are the dependencies needed in building that application. So from there, we can see that it's not an application aware based technology. I mean, you have to specify, you have to inform the Docker file, through the Docker file, that what kind of application you are going to build, right? It cannot automatically, let's say if it's a Java application, it cannot automatically pull out the jar files and start building all together. And also there is a mix of operation and application developer concerns while building this kind of a model. This comes to the fourth problem, which is a maintenance. So maintenance is again a problem, especially when you try to do different versioning of that application. Specifically, since it's more of a manual effort, there is an error that introduced in copy pasting the code, which again, it's a tedious and time consuming job. So when we think about the kind of shortcomings that we see in Docker file, what is the alternative that we can think about? So there is one alternative that is there, and that is quite relevant in today's app modernization ecosystem, is something called as a Buildpacks. Now, Buildpacks is one of a very older concept which actually came from a company called Heroku, right? So it was basically created to provide certain pluggable modular tools that translates your app source code into a compliant image, which was more OCI native. And the important thing is that it provides a high level abstractions for building an applications compared to a Docker file. You don't have to specify the app dependencies directly about what kind of app you are trying to bring into your platform, right? It is quite intelligent enough to know and basically build the dependencies around it. As I told you, that it was first initially conceived by Heroku, but then later it was adapted by multiple organizations like Cloud Foundry, VMware, companies like GitLab, Knative, to basically build it and make it more modular to work with the cloud native ecosystem. Buildpack in general works with three different philosophy. One is the bins detect, to basically help you to detect what is the kind of an application development platform that you are trying to run. And basically the second is about the compile. So compile is nothing, it's more when you detect the kind of an application development platform, you need to basically set up or try to fetch the corresponding plugins or the artifacts that would be needed in basically building those particular applications with that particular development framework. And then the release is something where you finally build out the artifact and expose it and push it to a OCI compliant register. We'll actually discuss more about this later. Now, when we discuss about Buildpacks, we talk about more in the cloud native side, like how we can basically use Buildpacks to help in building a more robust workflow in creating an OCI compliant image. And there is something which comes, there is something which basically leads in creating something called as a cloud native Buildpack. So Cloud Native Build Pact as a project was initiated by Pivotal, which is now actually part of the VMware Tanzu and Heroku in Jan 2018. And currently, this is again a CNCF project which is in incubating stage. And the motto of this particular technology is basically to help in unifying the context of creating a well-defined platform to build back contract, which allows developers more control over their applications. So the idea here is to help developers ease the process of making an image, specifically a more cloud native image, which where the focus would be more to build or to write more uh, good application code rather than focusing on the dependencies which is needed to build that particular application. So, in a nutshell, Cloud Native Buildpacks takes your source code and creates into a compiled OCI image which contains multiple layers called as a stack image layer, runtime layer, dependency layer, all together that is built on your application. So there are multiple components within Buildpack which basically helps to serve this purpose. So Builder is basically an image which bundles all your bits and pieces of informations together that basically serves as the base platform to build that image. So basically you can think about that using the Builder, you basically execute the whole stack which comprises of the build packs together with the life cycle. We will discuss the life cycle a little more in the later phase, but it is a way of how Buildpack tries to build that image from the scratch actually. And the stack is basically nothing, comprises of a build image and a run image. The build image is something which basically provides the base layer on which your build environment is constructed, where your actual life cycle would be executed. The life cycle is the Buildpack life cycle, which I'll discuss. While the run image basically forms the base image on which your application would be deployed. So when we think about like from the context of Docker file, it would be more about selecting the correct base image, let's say from Ubuntu 20.04 or let's say from CentOS 7. So that becomes a base image. So here also it becomes a run image on for your stack from where the builder gets the information of how it needs to run that particular image that you are going to deploy. The build pack basically inspect your application source code and formulates a strategy or a workflow how it is going to build and run the application. Precisely, it comprises of three different files. One is a buildpack.toml file, which provides the complete metadata about the buildpack. So the metadata is nothing, but it contains all the root dependencies, the configurations, the application libraries, which your buildpack comprises of, which are actually extracted at runtime during the buildpack lifecycle execution. While detect is more about where your platform detects the type of application that you are going to build on your environment. Bin/build is basically executing the buildpack logic. It basically signifies that once it has detected that which buildpack should be applicable for your application, it determines and runs the correct builder logic on that particular run image. So here is the life cycle which I was talking about. The life cycle is nothing but it orchestrates the whole process of buildpack creation. So it basically starts from detection phase where it selects the optimal set of buildpacks and what it is going to be applied against that application image. Now, here in this case, you have the provision to provide multiple build packs, even though if it may not be used in your environment, but you can still use that because you can use the same builder file and you can basically use it to build multiple applications together. So that's why the reference that you can put a multiple build pack reference here in this context. Second is about analysis, where the metadata about the OCI layers are generated and these are made available to the build workflow. So here in this case, what happens if you have already run a build information earlier, it would tries to fetch certain metadata information from the executed build and tries to apply it in the current build workflow. Restore is the process which basically fetches the cache information from a previous build. So this is very useful in case you are running multiple build processes. In that case, what happens? It doesn't rebuild your image continuously. So what it does, it rebuilds at one time, and in the second time, it only takes the information which is stored in the caches directory and only applies the new informations which gets added to it. So it is more about something we will discuss later, that is called as a rebasing, where it basically it removes the layer from down of the stack and adds a new layer on top of it, keeping the whole stack as it is, keeping it same without making any changes. The build is basically where your build packs are available to use available metadata to generate the OCI layers which needs to be replaced. While export is something where basically the remote layers are replaced by the generated layers and the final OCI image is constructed and pushed directly to the registry. So in the case of a build pack the work life execution, you don't create any image locally onto your system. So you always have a registry where your builder would be deployed, or the builder information would be stored, and the information would be fetched at runtime from that particular registry. The image would be created and then it would be pushed back to the registry. So one of the prerequisite is to have registry informations before you execute this particular builder lifecycle. So coming into something called as a stack, which is quite relevant to understand because it forms the core of the build pack lifecycle. So stack is nothing but it contains the build image and the run image together. So what it happens actually, the builder image basically the stacks are basically the combination of a builder image which contains the image needed to construct the build environment where your lifecycle is executed. So the source together with the build image gets combined through the build pack process, and together with the runnable image or the base image as fetch from the application goes into the application image. So the final app image that you get contains all the required dependencies that is needed to build that particular OCI component image together with the base image on which your actual application is built. One of the important concept of one of the important advantages of using build packs is that it allows image rebasing. The rebasing is a very is an important is a crucial feature in case where you need to basically update your base OS image. Let's say, for example, it may happen that you need to update your base OS to a new kernel version. Now, in that case, you don't want to build your whole application from the scratch. So what you do, you simply do a rebase. What it does, it simply displaces the older base OS image that is created for the application with the newer image, keeping the overall stack as same. I mean, it won't displace anything. So so here you get two advantages. One is that the build execution is faster. You don't have to wait for the entire build fact phase to happen. I mean, you don't have to wait for the entire execution phase to be completed because those are anyway skipped. And the second thing is that you can easily do that at runtime, depending on the kind of application that you're supporting. Obviously, for critical applications, we don't suggest to use that at runtime because there can be certain downtime. But in most of the applications, if you are doing for development purpose, you can do this at runtime. So this also leads to understanding how the security patching can happen for a day to operation model. So what happens if there is a new change in the existing OS image? As I was telling, it would simply there would be a metadata information that would basically be fetched from the build pack layers, and it would be fed to the newer updated OS image, removing from the reference which was given to the existing OS image. This is possible because both the images are ABI compatible in nature. So sometimes it often comes that, okay, so if you are using Buildpacks, so I mean, is it still that we need to use Docker in this case? I mean, is it that you need to run Docker? Okay, I mean, it is not required, but then again, it is. I mean, you can still have it because you don't really require Docker to run. I mean, you can use any other container runtime environment for using Buildpacks, whether using Podman or something else. But there are certain facts where you need a registry. So you can choose whether you want to use a Docker registry model, or you may want to use any third party registry, such as let's say, for example, you can use Harbor registry, you can use JFrog registry, you can use Google Cloud registry for that. But you need one registry, because whenever you are building the builder configuration or the builder artifact, you need to store it some registry, which has to be driven at the runtime during the buildpack execution to create the final OCI compliant image that needs to be again exported and shared onto the OCI registry, to the registry that you are basically connecting to. So you need some registry for the access during the buildpack execution phase. Else the buildpack execution, it doesn't succeed properly and it fails in exporting the image. Okay, so we discussed a lot around the cloud native build packs and how basically it helps in building a more robust OCI compliant image. But how we think about using build pack for the future, because ultimately, as a developer, I may think, okay, I have a platform like, let's say, Kubernetes deployed on my environment. Now I need to use some way, I need to use some tool that can basically help to use this workflow that Buildpack is guaranteeing to in my environment, in my local environment, for building the application. So there is something which has been developed for that purpose, which is called as an kpack. Kpack is basically nothing. It's a Kubernetes native container build service, and it's a part of the VMware Tanzu build service portfolio, which is again using the underlying logic of how Buildpack basically executes in creating an OCI compliant image. So what Kpack does, basically it extends the Kubernetes API, basically creating a bunch of custom resources that basically helps in building an OCI images. So it provides basically, so every resource that we discuss about, whether it's an image, a stack that we discuss, a builder, are basically created as a declarative resource model through this kpack. And basically using that, you can basically define, like for example, if you create a builder resource, you can declare what should be the desired build pack order that you are going to run for your application. Secondly, you can basically use an image construct to define that how you're going to fetch the source code. So you can basically provide the direct link of the GitHub repository from where the source code would be fetched, and the corresponding metadata information would be taken, and then the build pack lifecycle would be executed. And then basically you provide a complete builder lifecycle workflow, that how you are going to execute to create that OCI compliant image. I mean, all this workflow are defined using a bunch of custom resources, which we would see. And this is, again, as I told, is maintained under VMware Tanzu currently. It's a current OSS project, and that means, I mean, anyone can use it and deploy in their environment. It doesn't, it doesn't construct that you have to run on VMware platform only. You can run that maybe on or OpenShift platform. You can run that on Google Cloud platform. You can run on Amazon EKS, anywhere actually. Okay, so enough of technical discussions. So let's quickly see a bit demo, else it would be a little bit too boring. Okay, so let me bring up my terminal, and I just want to show. So the demo that I'm going to show today would be on a Kubernetes platform, which I have deployed using Tanzu Community Edition platform. So VMware Tanzu has a community offering, which is called as the Tanzu Community Edition, which I can show maybe here, which is again a single platform that can be deployed onto cluster. Let me show. So this is again an open source Kubernetes distribution, which you can try out in your system. There are, I mean, multiple ways that you can deploy. You can basically set it up as an unmanaged cluster, as a single node cluster that is deployed using a kind provider, or basically you can use it to deploy across multiple providers as well. I mean, you can basically deploy that you on your AWS platform, in your Azure platform, and that is a very quick way that you can start using Tanzu functionalities. There are a lot of features that is embedded to it that you can directly use with this. But I'll not go and explain that because I just want to show what Tanzu platform is all about. So let us go to the terminal back, and as you can see that I have already just set up the platform just to save some time. And if as I was mentioning, mm, so Tanzu offers a set of features that you can use directly means that you just need to install that. This comes as a prepackaged binary. The services such as Gatekeeper, Grafana, or if you're trying to use any OCA registry privately, you can use that. If you try to use Knative serving, it is also possible. You can directly install it here. I mean, that is very much possible. So that is the flexibility, and I'm just running as a single node cluster in my environment. Okay, so to use or to start with kpack, you need to install the binary. So I have already installed, and if I just run the kpack version, so kp is again a short form of using the kp CLI, and this is the current version that I'm running. If I just give a help command, you can see what are the different commands that is available that you can use for your buildpack execution. We'll be using most commands today to see what it how we actually run this complete buildpack lifecycle execution phase. So to use the KPCLI or the KPAC CLI, you need to basically, as I told you, that we need to deploy a bunch of custom resources. So KPAX has the CRD resources that you need to deploy first. So I'll just deploy that. So I mean, it's, yeah. So as you can see that this is the link. Maybe I can just show you the release this just for your reference. So here you can go to the KPAC releases and download the appropriate release from here. So I have already set it in my environment, so I can directly use that, or I can just copy here and run it in my environment. So this is the latest release as for now, which is available. So what it would do, it would basically create a bunch of Kubernetes objects in my current in a kpack namespace, and creating two pods. So let us see whether the pods are running or not. Okay, they are creating. So I'll just keep a watch status. So it basically creates one controller which basically helps to set up the or basically execute the whole buildpack lifecycle phase, and the webhook which basically listens on for the new the request that is coming while we push the image that we are trying to build from the source to the platform side. So that's why it's called as platform to build contract actually. So this is now running as we see. Yeah, they are running very well. And if I just check the resources, I should see some new resources being created in my environment. Yes, so you can see it basically creates resources like builders, builds, cluster builders, cluster stack, cluster stores, stores and images that you can use for this build pack configurations. Okay, now basically you can use the concept of kpack in two different ways. Either you can use the kpack CLI directly to build the resources, or you can directly use the kubectl resources. If you are not so familiar, I mean, it works seamlessly in both the ways. So I'll try to show in a more generic manner so that it can be used in a wider environment. So to use KPAC, as I told you, the first prerequisite of basically setting a buildpack lifecycle phase is to use or basically first you need to uh, create a secret. That secret is nothing but the Docker the registry that you would be using for your environment. I already did that in my environment. Just so that I can save again some time. And this is a secret that I'm using. And this secret defines the credentials that I'll be using for this particular demo, which I'm using a Docker a registry in my case. Similarly, when you are using this registry, I need to create a service account. So I have already defined the service account here through these YAML definitions, and I'll be using the secret. So let me create that, and the service account is created. Now, the first thing that once you create the service account, the first thing that comes is you need to basically define the cluster store. Now, as I was defining, the cluster store is nothing but it's the definition of the different Buildpack source that you are going to use for your application. It's not necessary that you are going to put all the Buildpack source. You can just put one Buildpack source if you know the type of application that you are going to build here. But in this case, I have just put multiple Buildpacks just for reference, just to show that it can be done. And so first is you need to create this cluster store configuration. So I'll just create that, and this is done. So I can use KP as the command line tool to basically view the status of the resources. So as you can see, the cluster store status is ready, and it has all this Buildpack. It has basically built this Buildpack configuration with the correct versioning. Together, it has given the GitHub page that you can refer to. Okay. The next thing that comes is basically building the cluster stack information. Now, cluster stack again is basically a reference to the build image and the run image that you are going to use for the build pack configuration, and the together the base image for this build. So I'm just going to use a very simple bionic image in this case, and for the build image, I'm just referring to the Paketo build packs for basically providing the base image to create the build environment where my build pack lifecycle would be executed, and the run image is basically the base image where you would be actually running, or you would be actually deploying your applications, right? So let's create this as well. So this is needed. Okay, so I'll just check the status as well. Cluster stack. So base. Yeah, as you can see, this is also in ready conditions. It has an ID that I have configured here, and the run image and the build image. So this would be used as a reference in the builder configuration, which I'm going to create the next. So I have the builder logic defined here in this YAML. So this is where basically I'm defining the builder configuration, where I am specifying the service account to specify the registry where the build where this is going to push a bunch of metadata informations for that particular build pack during the execution phase. It basically uses both the stack and store configuration, which I have defined earlier. So that's why it was prerequisite to define it earlier. And then I mentioned the order. This order determines the build pack order, that how you want your build pack to run. So for example, I know that if I'm going to deploy an Go application, so I may specify that at first. So what it would basically extract and all the dependencies, the configurations and libraries together with that, and then it would basically do it for the Java node. Just it's kind of an ordering that you can decide that which build pack would be executed based on your application that you are going to run. So let me deploy that. Okay, I deployed that, and if I just see now KP builder status, my builder, it should show me nothing because it takes some time. So to see the resources in more details, let me describe the custom resource. Okay, so here, as you can see that this resource is described, and if you see it has already created the resource, and it is in the operation update. Okay, so it takes some time because it needs to create the set of metadata informations, push it to the registry where that is in my Docker Hub registry. Okay, so hopefully it should now publish. Okay, it's still in update state. Let's wait for some more time. Yep. So it depends on like it takes some time because it needs to push this metadata informations back to my Docker Hub. So maybe I can show here. I have it should ideally create now a builder repository. Yeah, it started creating. I think so. That means it's still pushing the informations back there. Yeah. So it did define. So it's now done. I can maybe run using the kp command just to get a more visible information that is needed. So as you can see, the builder is now ready. The image is specified for the builder, and then the stack ID that we have mentioned it earlier together with the run image. Here it basically uses the previous concept that we defined about the cluster store and the cluster stack informations. And then here is where basically it tries to get all the relevant dependencies for the build packs that we are going to use in our environment, right? So since we mentioned that we were going to use Go, Java, Node.js, so basically it had pulled all the relevant dependencies, the libraries, the configurations that is needed, those has been fetched, and the detection order has been specified. So this is actually put into different groups based on the type of build packs that we are trying to run. So now this is pushed. The builder is created. It is pushed to the registry. It's now that we can create our image. So to create an image, I have an image resource that I have defined, and inside that image resource, again, it's basically what I'm going to specify is the tag. Is basically the tag with the image that I'm going to deploy. It's basically going to point to the OCI compliant registry. In this case, I am basically using Docker, but in your case, you can use any other registry of your choice. The service account that you have to provide because it contains the credential information necessary to push the image, the builder that I've just created now, and this is important. This is the source information. So this is again the path, right, where your actual application source code has been created. And this is the revision nothing but the latest commit of the source code. So let me show you probably. So this is the application that I'm just having in my GitHub repository. And if you see, this is the revision that I have just updated. So this revision is nothing but the latest commit that you want to enable as a part of this image build process. Now, it's not necessary that you need to actually put always the revision history, but you can put the branch name as well. I mean, there are different ways that you can specify. You can get more informations in the kpack documentations, that how you are going to basically create or basically provide the source information. So this link you can go through, and basically you can get all the relevant informations, like how you're going to build the image and what is the tag. So if you see that you can specify different ways of building. So the source configurations can be passed as a URL, as a revision, as a subpath. As I was mentioning, you can directly provide the root informations to create through. So I like specifying the revision because it basically helps to it helps me to control, have more control on the image that I'm building. So that is basically why I have just put the revision here. But in your case, you can choose either of the option. So next, what I'm doing, I'll be just creating this image because I have all the prerequisites. I have already created the builder. I have the stack configurations. Okay. So once I create the image, next I can basically use the kpack CLI to understand the build logs, and probably I will just use this image name to see how the build pack lifecycle phase is executing. So here you can see it has basically started the execution. So it identifies that what should be the application source code that you need to build. So it basically identifies the commit from the YAML manifest. It looks and it clones the source code into your workspace directory, and then it would start the subsequent stages. So this is again dependent on the on the way how you are initiating the build. I mean, it may happen that you are running the build multiple times. In that case, this step is mandatory, obviously, because it needs to fetch the information. It needs to identify what is the change in information that has taken place. But for the other phases, it may skip depending it gets the repository or not. I mean, if it is already finds out that it has the cache directory, then obviously it would skip. So that it is done in the analyze phase, which it is currently doing. So let us just wait for some time to allow the build pack lifecycle to kick off. Yep. So as you can see that it tries to find this in the in my registry. It's trying to point out and see, and this app is not found. So it detects that what build packs are participating in the build pack execution phase. There's nothing to restore. So you see under restore, there's nothing, because this is the first time, I mean, this is first time that you are going to build the image. So there is nothing that I can fetch from the previous build. And in the build, it basically fetches all the relevant build packs informations together with the dependencies, which I've already created from the builder phase, and running the same here. And so once it is done, it basically export this as a kind of a read-only layers, adding each layer on top of the another and saving them directly to your, and I mean not saving, but you can say more of like exporting and pushing it directly to the index registry. So one of the important advantage using kpack is that you can also get the software bill of materials. Like you can see what are the build, I mean, what are the software artifacts that has participated in the build process. Okay, so the build is successful. Let me see. So if I just do a kp image list, it should show me that it is in ready condition true, and it is the latest image that it has created from the previous build processes. Now, basically, you can describe this as well, image describe, and then basically you can give this name. Oh, sorry, it's not describe, it's status. Describe goes for the kubectl part actually. Yeah, so here you can see the status is ready, what is the source that it has pointed to, and the builder references, successful build. So this is for the first build only, so the ID is 1. For the subsequent builds, obviously the ID would increment. And then the build pack ID informations. If there's any failure, you get the build message failure here. So your image is now built. So now you can basically use this image and you can run. So I have already created a simple deployment. Let me just copy first this index image here, and probably let me just check it here and change it. I just created this deployment file just to show how we can quickly use this. Ideally, I would not use this manually, rather we would try to use through any CI tool, so that once the image process is built, it should trigger workflow that would update the image in my in my existing YAML definitions. But just for the demo, I'm just showing that. Maybe you can also do that using the GitOps terminology as well. I mean, equally applicable. So let me do that. Okay, the deployment is created. The pod should be in, yeah, it's container creating state. Let me keep a watch on it. So I think it has already come up. Yep. So I can just do a port forward, deploy CNB, deploy, and let me forward to port 9000 just to see whether I'm able to access the applications or not. Okay. So what I will do, I'll maybe try to open a new tab here, or maybe I can show that in the my browser as well. That's fine. So localhost, and just give 9000. Yep. So the application is now up here. So as you can see, it's a very simplified way of actually I should not say it's very simplified way, but if you just try to uh, run this process in a so it would be kind of like you do it in a single time, like you would not be preparing the cluster stack, cluster store, builder informations every time. Now once you have built it, right, you need to basically set the informations that you are changing for the application source code into image definition. That is only the context, and that is what the devs are concerned to. I mean, they won't be going much into the details on the platform constructs to by understanding what are the new binaries or the dependencies that need to be pulled for any new subsequent change in the source code. So let us see how this happens. So let me go to the my GitHub URL and let me change something in my source code. Let's say welcome to GDC Cloud webinar on Gil and kpack together. Kpack, I think that should be fine. Yep, and update source code. So I just updated it, and I get a new commit. So I'll just take this commit. Now I need to build it again, right? So probably I would go here and I would open the image YAML file again, and I just simply replace this revision here. Now, in this case, if you're using the branch concept, you don't have to do, because that would automatically take that. Let's say if you're doing it in a development branch, that would automatically change that. And this would basically result in triggering a CI workflow that would basically trigger in creating or applying this change back to the image resource process. So let me save this and let me create, apply this change again. So this now is configured, and let us see the build logs to see how fast now it runs. So ideally it should now take lesser time, since it would get most of the uh, build informations from the previous run. So as I told that the commit or the configuration side is something which it has to go multiple times, because obviously the change would be there in the source code side. But as you can see that in the analyze phase, it analyzes the data, restores the data from the SBOM. So as I told that kpack is very intelligent enough to identify the artifacts that is needed for creating this particular build. Okay, and it identifies from the build image cache that it is storing in the layers, and then it is restoring the metadata informations. And so you can see it is now basically exporting the image. So compared to the previous build process, it's little bit faster. So now if I do a KP image list, I should see the new image being configured here. Now, if I just do a KP image status and then the CDC webinar, there should be two build ID corresponding to it, right? Because that is the second build that happened. And this is the newer build image process. So now what I can do, I can basically take this image and I can do a live editing of the deployment. Just need to change the image parameter here. Just need to change with the latest tag that got created. Yep. Yep, the deployment is done, and possibly the pods would be terminated and the new pods would be created. I guess so. Yes, let us just keep a watch to see the new pod being created. Yep, I think it's done. Yep. So I just need to the port forward request. Let me just see. Um, oh, sorry. I need to again do a port forwarding because the older pods got killed anyway. So yep, and then I just need to see here. Yep, as you can see, the changes has taken place here. So I mean, this is a very simplified way of how you can approach in helping developers starts the image build process in a in a while working with a cloud native platform. Basically, helping them making the image construct process less complex by focusing more on the app code logic, and you basically build the build construct the platform build construct for them, and then they subsequently make the changes as and when it is needed. So going back to the slides, I'll just show maybe. Yeah. So the advantages that we get using this cloud native build pack. So not only it basically helps the devs to basically run the image, but they are able to make it run in a more security and compliance manner, right? Because the image rebasing is something which you can easily do, replace with the more compliant image, or let's say if there's a CV that is identified, you can simply rebase the older image where there is where there is some criticality that is discovered with the newer fixed image, right? In the base on the base OS side, provides an automated delivery of both the OS level and the application layer dependencies that is needed, and you can easily handle the day-to operations. So the most challenge, the thing is that once the platform is set up, for the developers, they just need to go ahead and build their application, right? So this is the way how you basically complete or tries to create a complete build pack lifecycle workflow, and then allow them just to update the image construct by making the revisions or maybe changing the branch, and then they can simply build the image over and over again. Boost security and reduce risk from CV, which we understood, and only it rebuilds and upload layers wherever it's necessary. So it always targets the cache side first, so that you can simply check for the existing informations and then do a recaching or revalidating if that information is available. Suppose cross repository, Cloud Mountain, Docker registry v2. That means you can use this build pack across any registry that is supporting the v2 registry side. Okay, so this concludes my presentation around that, and I hope if there are any questions, I'm now able to take it now. And maybe, yep,
Yeah, sure. Excellent. I mean, thank you, Suman. I mean, that was like a very insightful and a deep down session. I can't call it like a beginner friendly. It was, you went deep, you went like through the full cycle of deploying the whole thing. So very insightful and detailed. We do have certain questions that's come up. So let me just pop that up on the screen on the reverse order. So
okay,
first one is, let me see if I can show it.
yeah,
Yeah. So from
yeah, I'm
Senthil,
assuming. Yeah, I'm
yeah.
assuming that kpack is not using a Docker daemon internally for building the image. Is it using Canic or Builder instead? No, Senthil. I mean, kpack is a whole new construct that is basically uses the extensive custom resource definitions from Kubernetes side to basically build this construct. Canic or Builder, as I understand, I mean, I haven't gone deep into the project, but they are completely different, but they can work almost in a similar way. But there are a few things in this through kpack which is not possible in builder configuration, like for example easily rebasing the base layer on the OS side in case of any CV that is that is detected, right? So you need to build that image all over again. So this is something which you get new from the kpack side. So I mean it's a bit different. I mean it's not the same as it looks to be. Yep.
Cool. Thank you. The other one is from, why is the
Okay.
revision hard coded? I think this was
Uh,
like something during the demo. Yeah.
yeah. So yeah, so as I told that you don't need to like maybe I can share again, maybe Runse, is it possible?
Sure, sure.
Or
Yeah, yeah, I can pop that. Yeah.
yeah, so let me show you. So you don't actually need to probably let me, okay, I think yeah. So let me go to the kpack image side, and possibly I can show you the different parameters that you can pass. So it's not necessary that you need to give the revision hard coded. As I told you, like if you go here, you have the option to pass the subpath as well. Okay, the subpath is something where you can specify the specific directory from where you are going to build that particular image. Now, in that case, you can provide, let's say, for example, you are creating from dev one branch. So you can provide that, and whenever there's any change, so ideally you should configure that on your CI side, so that if there's any change introduced, that CI can detect and automatically trigger this kubectl apply minus image process. I mean, that should happen automatically. So this can also be possible. Just for the demo, I want to show the revision because I just want to I just want to introduce the differences that I want to create between two changes that happens at the source layer. So that's why, but it is not mandatory that you need to push it as a hard code part.
Okay, great. So the other one is like we have one final one. So again from Central.
Hmm.
Could you please explain what are the cache directories and
Yeah.
why are they extraneous?
Yeah, so cache directories is something like, for example, when you build a Docker file, right? So there are some informations that are pulled from the internet. Let's say if there are certain dependencies, right? Now, let's say, for example, if you're building a particular, let's say, for example, you're building some some package need that has some dependencies on XYZ libraries, right? So these libraries are then cache stored into something called as a metadata layer within that whole image build process. So whenever you use the Docker file again, it will not pull it back again from the internet, but it will try to use these directories as a reference to pull the dependencies back into your Docker file execution. So these are the caches directories, which actually can become a bottleneck if you are building a very big application, because this actually, so this unknowingly basically gets stored onto your local disk, and unknowingly it takes up some space. And for example, if you have a very smaller teams, a smaller dev teams who wants to build up applications quickly, where you don't want to store much of the or you don't want to take up much of the disk space for building your image, then it can become one of the issue while using for a longer time. So that's why that is what I actually try to refer from the cache directories actually.
Cool. I guess that's it, Suman.
Yeah,
So we are out of questions. So I guess we can close the mic. And
yeah,
as a final thing, so thank you again. It was
yeah.
superb to be hosting you as part of the joint meetup with GDG Cloud and also the Cloud Native Bangalore groups. And I'm
Thanks, Ronsi,
sure
for
the session,
having me.
yeah,
I do love
sure, sure.
interacting with the community, and it's always great to, I mean, interact with the community, get many new, understanding around the technology and how that is being used. So, I mean, it's been quite, I mean, the community has been quite responsive here, and they have basically, I think they have completely gone through the demo. So that's why so many questions are coming, and that is something that inspires me actually to deliver good content. Yeah.
Yeah. So we had like a peak viewership of about 15 to 16 people, but I'm sure the viewership would just increase because this is available on our YouTube channel. So people usually,
Yes,
since it's like a Friday evening, people would usually sign off early and wouldn't want to be
plus it's a
involved with the
holy
tech.
day.
Yeah, and it's a holy. Yeah, so we
Right.
will keep increasing the views as we upload the video. Yeah, but again,
Yeah,
thank you again. So we hope to host you again. So until that,
thank
everyone. So it's Ransi signing off, and we hope to be back again with another great, exciting session. So stay tuned.
thank you everyone. Bye.